In question number 23, there are two statements. Statement 1 is statement A and B. First statement says that if two lines intersect, then vertically opposite angles are equal. So let's take two lines. Say this is one and this is another. Clearly, these are two vertically opposite angles. This and this are one pair of vertically opposite angles. And this are the other pair of vertically opposite angles. Yes, we know that when two lines intersect, the pair of vertically opposite angles are always equal. So the first statement is correct. Now the second says if a transversal intersect two other lines, then the sum of two interior angles on the same side of a transversal is 180 degree. Now let's understand there are two possible cases when the two lines are parallel, and let this blue ink color line is the transversal. Let's say make another pair of line. This time I'm not making these two lines parallel, but the transversal here again is this. Now it says that if a transversal intersect two other lines, then the sum of the interior angles on the same side of the transversal is 180 degree. Well, it is true when the lines are parallel. When the lines are parallel, yes, the co-interior angles, also called the interior angles on the same side of the transversal, is supplementary or 180 degree, right? Similarly, this plus this is equal to 180 degree. But read it carefully. It says two lines, right? Two lines. It does not say two parallel lines. Had it been two parallel lines, then the statement should have been correct. But it's not said. It's a two parallel lines. It's any two line. So therefore, the statement B is wrong, as it is not true in these two cases. Here, the sum of this angle plus this angle is not 180 degrees. So is the case of this, that this angle plus this angle are the co-interior angles, but the lines are not parallel. Reason being, it is not, the lines here drawn are not parallel. So therefore, concluding these two, we say statement A is correct, but the statement B is false. So statement A is true and B is false. In question number 24, it says for the given figure, the statement P and Q are given below. Statement P says that if A and B are forming a linear pair, check here. Angle A and angle B are adjacent angles, and you can also find that the sum of these two angles is giving a straight angle, that is 180 degrees. So statement A is correct. The statement is correct. Now, when we look into the second statement, it says A and B are forming pair of adjacent angles. That's correct. These two are adjacent angles. As you know, for an adjacent angles, what are the conditions? They should have a common vertex. Yes, O is a common vertex. They should have one common arms. Yes, it is also well shown here that there is a common arms, that is OC is the common arms, and the non-common arms are on the either side of the common arms. So yes, both the statements P and Q, or both the statement here is true here. That means this is the correct answer. In question number 25, it says in the figure AOC and BOC forms a linear pair. Angle AOC, I'm showing the angle AOC is this, and BOC is this. This form what kind of angles? Are they vertically opposite angles? Clearly not. For a vertically opposite angles, two straight lines must intersect. As we can see, these two lines when intersect, then this and this are called vertically opposite angles, same as this and this. But this is not the case here. Now the second one, they are complementary, not complementary. As you know that they are not forming, the sum of these two angles are not forming. Now, similarly, they cannot be alternate interior angles, because alternate interior angles are formed when two parallel lines are intersected by a transversal, and then these angles are called alternate interior angles, and they are equal if the lines are parallel. Now, we are left with the last statement, which says that they are supplementary. Yes, As you can see that they are forming a straight line. So therefore, this is the correct answer. That means these are supplementary angles. In question number 26, we have to get the value of A. Yes, we have to get the value of E. Now, first of all, let's check here that this and this are vertically opposite angles. Right? We can see here this angle, that means we are talking about angle A. Say if I mark this point as O, which is not marked here, as AOF and COD are forming linear pair. And sorry, a vertically opposite angle, not linear pair. And in case of vertically opposite angles, they are always equal. So I can write this angle as 90 degree. This being 90 degree. Now, this is a straight line. This is a straight line. This BE is a straight line. So you know that sum of all angles in a straight line is one angle by linear angles property. So we can say that angle, this angle 40 degree, the other is mentioned 90 plus 5A will be equal to 180 degree. So 90 plus 40 is 130. 130 plus 5A is equal to 180 degree. So that means 5A will be equal to 180 minus 130. So 5A is equal to 50 degree. So A is equal to 50 divided by 5, that is 10 degree. This is what the value of the one which were required to find out. Question number 27, a very important question. Here it is mentioned that there are two lines, say this one. QP is given parallel to SR, and we had to get the value of angle A. We have to get the value of this angle A. So for this, as you can see, we cannot see any transversal. So there is a construction needed here. So what you are going to do, through the point T, we will draw a line parallel to any of them. Say, you can write, say this one, parallel. Two lines which are parallel to the same line are parallel to each other. And mark these points. Mark this point, say you may name it as M and say N. Now let's see. Consider these lines. Consider only these two lines. This at a time, this and this line. Consider these two lines. Now, and take this as the transversal. This one. Taking this as the transversal, we can see that these and this are forming alternate interior angles, and alternate interior angles are equal if the lines are parallel. So we can write the value of this angle. Say I'm taking this angle as M P Q will be equal to 60 degree, as alternate interior angles are equal. Now, in the next case, consider the other two lines here. One is this, that is MN. Consider this line MN, and the other line as ST. Check here also. There is a transversal, and what is the transversal here? Marking with blue ink. This ST is acting as a transversal. So by using alternate interior angles, this angle will be equal to this angle. That means we can say angle MTS is equal to 30 degree. Now we got these two angles. Now you can clearly see that this angle A is actually sum of these two angles. So if I add these two angles, I'm adding the angle MTQ plus angle MTS. That should be 60 plus 30. The sum of these two angles is nothing but angle A. So angle A comes out to be 90 degree. This angle is 90 degree. In question number 28, there are some four figures given, and thus are named A, B, C, D. Figure A, figure B, figure C, and figure D. We have to find out in which cases they are pair of adjacent angles. Right, for two angles to be called adjacent, there are three conditions The condition or the criteria is that they must have a common vertex. They should have a common arms, and the non-common arms should be on the either side of the common arms. Now let's say these two angles, clearly angle A and angle B, like you can see there is a common vertex, that is, this is the common vertex. It's the common vertex. But there is as such no common arms. As you can see, arms of this angle A is this, and the arms of this triangle, this angle is this. So there is no common arm, so this cannot be the option. Now look into these two angles, the second figure, that is figure B. As you can see here there are, this is the vertex for the first angle and this is the second vertex for the second angles. Again, they are not common, right? So therefore, this cannot be true. In the third part, we can see that there is a common vertex. Yes, there is a common vertex. Now, when we look into the arms of angle, say A, angle A is this whole angle, right? This is angle A. That means starting from here, initial ray is A1 and the terminal ray is the other. This is angle A. So their arms, as it is clear from the figure only, there are two arms. This is one and this is the other. Now look into the angle B. Angle B has two arms again. This is one and this is the other. But when you look into this, they have a common arms. That is, this is a common arms, right? But the non-common arms, that is this and this. As you can see, the non-common arms are on the same side of the common arms. This should have been either side, one on this, other on this. So therefore, this is again not adjacent angles. Look into that, the D part. Yes, it fulfills all conditions. That is, one is common vertex. They have a common arms. Yes, this is a common arms. And the non-common arms, that means this one and this one, they are on the either side of the common arms. That you can see here, one is to this side and the other is this side. So it meets the requirement of adjacent angles. Therefore, this should be the correct answer. This is the correct answer for adjacent angles. In question number 29, related to the previous one, it says, in a pair of adjacent angles, what are the conditions are there? Number one, they have a common vertex. They always have a common vertex. Yes, it is true. They have a common vertex. The next says it has a one arm is always common. That is also correct. This is also a condition for a pair of adjacent angles. So this statement is also correct. That is, they have a one common arms. The last, the uncommon or the non-common arms are always in opposite rays. They not necessarily be in opposite rays. They must be on the either side. Like say, for example, if I draw these as non-common arms, and let me this be the common arms. This be the common arms. So looking into these two angles, that is say angle A and angle B, they are adjacent angles. But as you can see here, the non-common arms, one is this and the other is this. They are not opposite necessarily. One condition, they may not be opposite. They may be anywhere, somewhere here, anywhere between them. So therefore, here the statement, we are just looking for the one which is true. So what is that? So yeah, statement 3 is false. All other statements are correct. So statement 3 is false here. In question number 30, there is a figure drawn here. And these are lines mentioned, that PQ is a line and ST is also a line. And they are meeting at a point, say O. Further, it is given to us that this angle is given as 90 degree. This angle is POR is given 90 degree. And the other two angles, that is X and Z, X and Y, they are in the ratio of 3:2. Now, in questions of ratio, we assume these angles, like say this angle is, we can take X as 3 times of any variable, say A, and the Y will be 2 times. 2 times a. Make sure you do not take x as 3x, right? You have a tendency of taking x as 3x because we cannot take the same variables. Now, taking this angle as 3a and this being 2a and this being 90, we can apply linear equations and linear angles. That means angles, sum of all angles in a straight line is 180 degree. So it's clear that this is angle 2a plus 3a plus 90 should be equal to 180 degree. 2a plus 3a is 5a plus 90 is equal to 180 degree. So 5a is 180 minus 90, that is 90, or a is equal to 90 divided by 5, that is equal to 18 degree. Once we get the value of a here, now let's see what is the question, what they're asking for. They're asking for the value of z. This angle is z. So before we get the value of z, we should first ascertain the value of y. Why I'm saying so? Because we can clearly see that this angle z here, this angle z and y, right, is forming a linear pair. So if you know the value of y, in case if you know the value of y, we can get the value of z. So y is what? We have already written y as, y is this, right? 2 times a. Y is equal to 2 times a. And we have calculated the value of a as 18 degrees. So we can write 2 into 18. So y comes out to be 36. So once we know the value of y, we can find z. We have already calculated the value of a. Now we know the value of y here, and we can get z. Relation here with z and y is very clear. That means z plus y is equal to 180 degree by linear pair. So placing the value of placing the value of y, which is 36, we get z is equal to 180 minus 36, and that is equal to 144. So therefore, this comes out to be the correct answer.